our mechanical. Hello guys, welcome back to Architectural World. In today's episode, we'll be learning how to do our mechanical drawing and also electrical, but we'll be focusing basically today on mechanical because at the end of the video, you should be able to understand what mechanical drawing really means and how it works. So from a subscriber, he said, please sir, can you do a tutorial on how to draw structural, mechanical and electrical designs? I always tell you guys that structural design is based on the building you're designing. So it's not something that we can teach you. It's something that you need to be grounded on. Let me take you to a floor plan. Now you see this plan you see here, this plan you see here is a duplex. This is a three-bedroom duplex. You can see very well. This is a three-bedroom duplex. The structural plan of this design is basically on how this building load is being calculated. So if you want to be a structural engineer, it's going to take you a whole lot of energy and time for you to go through it. So I will advise you guys that whenever you run a plan, whenever you run a plan for the health and safety of your occupant or your client, contact a structural engineer to do the technical part of the building because structural is very technical. I can do it. It's not like I can teach you guys, but if I teach you guys, I'm only going to be teaching you guys one method, and that method is what you guys will be using. So let's assume that we're doing a job of this one-story duplex. This is a one-story duplex, I think so. Let me see if I can see the 3D. Sorry for the long process. I'm just trying to break some things to you guys. This is a one-story duplex. This is a one-story duplex. Yep. Okay. This is a 3D. This is a one-story duplex. Let me show you. It's coming up. Okay, you can see very well this is a one-story duplex. Now, this one-story duplex you're seeing here, the structural plan of this duplex is different from another structural plan of another story. So if I told you now, the only secret I can lead to you is that the minimum length for a column to be introduced is this and the kind of column to be used is this and this. So if I should teach you a structural detailing within a short period of time, are you really sure you can grab it to the point that you'll be doing a standard job? That is the question. That's the reason why you see I'm not bringing structural into the system. So whenever you're designing a story building, I'm advising my subscribers, whenever you are designing a story building, after you have done the design, the architectural, electrical, mechanical, contact a professional structural engineer. Contact a professional structural engineer to give you the complete detailing because structural engineerings are, let's say, these are other field, other aspect of studies. You understand? Because we have loads that will be calculated, we have life load, we have dead load, we have wind load. So there are a lot of things attached to structural detailing. That is the reason why I'm not doing it for you guys. It's not like I can't do it. Not like I can't do it. So I hope that solves the first request. It said we should do structural drawing. So that is out of the picture. Design your architectural, electrical, mechanical, and contact a structural engineer to analyze the other one. Now, mechanical. Let's dive into mechanical today. That's what we'll be diving into the mechanical. So I'm going to be using this as a work environment. I'll copy this off. I'll copy this. This is what I will be using as a work environment today. So copy this. It's just going to be a brief class. It's just going to be a brief class. So I'll copy this to somewhere here so I can be able to play with it. Okay, I don't want to mess up my design. So that is why I copied. Okay, now let's go. I'll delete all the space. Because mechanical, you don't need all this detailing. So you can be able to see what you are doing. You don't need all this detailing in mechanical. Okay, let's go. Okay, let's see. Sorry for that. I have to delete all these off. Okay, okay, almost. Okay, that being done. Okay, deleted. Okay, deleted. So now, what is mechanical drawing? Let's use our Chrome to get that done. What is mechanical drawing? Mechanical drawing. Let's check something, guys. What is mechanical drawing? You can see when you heard about mechanical, there is one thing you need to understand, that mechanical is basically the toilets. Mechanical engineering is basically the toilets. Yep. Mechanical system drawing is a type of technical drawing that shows information about heating, ventilating, air conditioning and transportation around the building. You understand? So this is basically the mechanical. So when you come to a building plan and you want to go into the mechanical, it's a technical drawing. It's a technical drawing. Now let's go to the part where it's technical. Now this is the building. This is the building. Now what is technical about this mechanical now? Is the toilet. Now wait, let me clean the other part so you get it clear. Let's reduce this occupant so the structure will be clean. Let's clear this side. Not all. Let's just clear over the side. Okay. Okay, now this is mechanical. Now we need to calculate the water flow is technical here, the toilet is technical and the chamber. So we come down to our object. You come to your design tools, you pick your object tools, you come down to this part, the settings, you search for toilet. Okay, you search for WC. Okay, perfect. Now you can see these are the mechanical parts. So you pick a WC of your choice. You're not doing a 3D, so you don't need the fancy one. You come to this part. You now, as a mechanical engineer, you know that the right place to place this WC is at the edge. Is at the edge, is at the center of this toilet to in order for you to have easy flow. Is the center of this toilet. That is the best place for this WC to sit at. And if the WC is sitting at the center of this toilet, it simply means you can easily connect your 4-inch pipe, your waste pipe, to flow direct to your soakaway without you experiencing any stress. Take note. Then secondly, you come to basin. I'm only going to show you what you need to do in mechanical aspects. Now secondly, you come to basin. Okay, these are WC baths, taps and fountains, sinks. Okay, we come to these are bath tube, we come to basin. Okay, let's look for basin. Now we have gotten basin here, so we don't need the fancy one because we are not doing elevation like I said. So let's pick this basin and click OK. So once you click OK, now the next thing you need to know before you place your basin is the opening of your door. Which side is your door opening to? Now you see that my door is opening this way. It's opening this way. So I can place a basin here. You can see, let me show you something. I can place a basin here. This is why it's called technical drawing. I can place a basin here. You need to arrange the compartments. Now, if I place a basin here and when this door is being opened, the door is going to be constantly jamming this basin and it can't go beyond this part. So which means placing this basin here is wrong. And me taking this basin down to this part for the door to be free is wrong because I have a lot of space here to play with. So a situation like this, you need to move this basin to this part. This basin has to be moved to this part. Let me show you. Okay, it has to be moved to this part. Then the size has to be reduced because we have a smaller basin. Now guys, you can see that you can access this toilet. This is a visitor toilet. You can pass this visitor toilet freely without this door having issue with this basin. and without this door having issue with this particular uh, toilet seat. So now this is a visitor toilet, which you know very well that not all visitor toilets carry shower, but some do carry shower. But if need be that you want to put shower, this part will sit on the shower. But if you don't want to put shower, since not all visitor toilet is carrying shower, I'm not going to be doing that. But you can see the next thing that you need to consider here, which is optional to you, is your floor drain. Is your floor drain. You can put your floor drain here. Put your floor drain here. Now this is floor drain. Let me show you. You can put your either here or here. Any of this side is okay. This is your floor drain. This is your floor drain. But if you put your floor drain here, you'll be having excessive waste of pipe. But if you want to save consumption of material, you can put your floor drain here. I'm going to show you why when I'm doing the detailing. So I come down to this side. I have store. I have another toilet here. So I'm going to copy all this. I'll copy all this down to this spot, then I will rearrange them. I have a toilet here. This toilet sits exactly at the middle. Okay, then let me take this off. Right here, I have option. I have enough option for this basin, so I'm going to take this basin to this part. You look for the closest safety section and put your basin. Okay, you can see I have my basin here, so automatically it's cool. Now I'm looking for my shower. I'm looking for my shower. So the best place for me to put my shower is right here. Let me show you. Let me go to my design tools and pick my object, then come to object setting and go for shower. Shower. Am I going to have that? I think I don't have one month tap. Okay, let's use this as a shower. Let's use this as a shower because basically that's the setting. So I can either place my shower here. I could either place my shower here. You can see I could either place my shower here like this. I could either place it here like this. Okay, like this. Okay, I could either place it here like this or place it here or place it here. But since this toilet is long, I don't need to place it here so that I can be able to avoid water. Let's assume during your construction or some errors were made, so the wall has to be soaked. Let's just assume. So, and this is my closet. If this wall is being affected with water, it automatically affects the closet. So the shower is best it sits right on this spot. Yeah, best it sits right on this spot. So after that, I come to my laundry. Laundry, all I just need here is floor waste. I need floor waste and water. I'll bring this floor drain to this part. This laundry. I can put it anywhere. Then I'll run in water later. I'll run water later. And this is my kitchen. Now, what do I need to do in my kitchen? In kitchen, you don't need to go to settings to pick your kitchen tools. You just need to come here because it's basically all about lining. So I'll just come here and take my line tools and create art how the cabinet ought to be. So this is my opening door. So and this is my window. So the down cabinet will come this way, starting at let's say 600 millimeter. Sorry, my dimension is on inches. Let me change my dimension. Okay, let's say the down cabinet should come at, let's just use what my dimension is sitting at. The down cabinet will come as 2 feet. The down cabinet will come as 2 feet. Let's do it this way. It's supposed to be 600 millimeters, so it will come as 2 feet. Now let's say if we have the down cabinet like this, if we have the down cabinet this way, you come to this way, you have the cabinet. This is automatically the best way for the client to understand what he's doing. Now you can see this is the cabinet and a center cabinet is highly needed in this kitchen. The center cabinet is needed. This is doing the furniture. This is not your job. This is an interior job. This is not your job, but you can decide to put it. You can decide to put it if you really want your drawing to be complete. You indicate it. You indicate it here for them to know. Okay. So now this is the cabinet. This is not the cabinet is not our concern. Cabinet is not our concern. Our basic concern is the water flow into this place. So the closest distance for water, the closest distance for water is the option you take, and that closest distance is this part. So right here you put your sink here, you put your sink at this middle, you put your sink at this middle. Now let's take this as our sink. This is our sink. You can see very well. This, let me change the model to red, or let me use blue. I think so. Okay, this blue here is our sink. So these are for cabinet and these are for cabinets. So this blue here is our sink. The reason why I take this blue closer to this part is because I can easily run the waste and water this way, coming to this way, than running all everything. Now let's assume I put the sink here. I have to run through this part, and that is waste of material and long distance of slope. So if I'm done with this, I'm done with the ground floor. The next one is the main floor. So I'm not going to be doing the main floor today. I'm just going to be working on the ground floor. So now this is the ground floor. What do I need to do? Before I continue anything here, before I connect this toilet fittings, I have to do what is called site analysis. Let me check if I have it here. Okay, perfect. Site analysis. You can see this is my site analysis of that building. Now from this site analysis, this is where I will now know where is my safety tank, where is my borehole located, where am I going to put my tank, where am I going to put my soakaway. You can see from my design here, this is my borehole, and from here, this is my tank. Then from this section, this is my toilet, this is my soakaway. So my soakaway is at this end. My soakaway is at this end because I have enough space in the compound. So which means if my soakaway is at this end, which automatically means I have to bring this back. If my socket is at that angle, that means it's best I have this seat, this toilet, this kitchen sink on this section. Let me show you. This toilet seat is basically the best on this section. I can start to put it here. Perfect. So this sink is best on this section. You can see it's best on this section because my sockaway is coming here. My sockaway is coming here. I'm having my sockaway here. So the closest distance to the sockaway is what I just changed that stuff to now. Now I want to connect this stuff. I want to connect this stuff. I'm just giving you a preview. I'm going to do a complete detailing on mechanical. I'm just giving you an insight on how it looks like, so that when I'm doing the complete detailing, you will not look as if maybe you don't know what you're doing. So now this is my sockaway, and from my design, for my site analysis, my tank is located at this spot. For my site analysis, my tank is located at this spot. So which means I have to go for my water level. Now this is a water level. First, there is what we call water outlet and chamber outlet. I'm going to come into that. So this is my water level. I'll bring this here. This is water. I'll bring this connection of water to this spot. Then I'll bring it to this spot. I'll bring it to this spot, and I'll bring it to this spot. Okay, that being done. Now this is water. This is water. You can see very well. Let me change to blue. Let me remove it from dash and use a straight line. Okay. Now this is water. This is water supply. This is water supply. Then from this water supply, I have to bring that the connection. I have to bring out the connection. Okay. I have to bring out the connection. This connection automatically, this water. I have to come down from this spot. Then it's going to be on wall. It's going to be on wall. I have it here. Then I'm having it here also. Then it runs into this pipe. Okay, it runs into this pipe. Now let me explain. This is the pipe and this is the pipe. We have a floor drain here. We have a wash hand basin here that makes use of water. You understand? We have a washing hand basin here that makes use of water. You can see this washing hand basin water will be connected to this part. Then this toilet, we have the taps here, like something like this. We have the where we want to put the angle, the the valve. Okay, we'll come down here. We have our water connected to this for our toilet, bumper wash and the rest. This is where the water is connected. We'll connect the water from here to up of the sink. Then this being done for this, we'll come down to this part. We have the same similarity here. We have the same similarity here. We have the water. This is facing the wrong way because we can't bend the water that way. So we have to take this to come to this part. Perfect. So we have our water here. We have our water line here. We have our water line here. We have our water line here. Then we are having our water line here also. Then we have our water line here. So since we already have the water line here, we don't need to drag this water to this other angle. We can create this supply to this toilet from this angle. So we have it here. Then we have it connected to this. You can see this is the connection. This is the water connection. This is water connection. This is the water connection. This shower supply comes from this part. And likewise any tap that you intend to put. Now let's assume we intend having a tap here. We have the tap supply from this part also coming to this way. So this is going to be for tap. Let me indicate it. Tap. Okay. Okay. This is for tap. This for tap water. Let's check it. Now this for tap water. Then what is the next? The next is the laundry. The laundry needs water. So we are going to create a supply. We're going to create a supply to the laundry for the washing machine. So we create it here. We create it here. Then we'll come to this way. Come to this way. We already created this water. So what is the next pipe? All this pipe has to be labeled. All this pipe has labeling. That's why I say my next class, I'm going to be bringing a complete tutorial on how to go about it and the complete labeling. I just want to drop this. If this solves your problem, please don't forget to subscribe to the channel and don't forget to turn on the notification bell. So the next pipe you need right now is your 4 inches pipe for waste. Now that goes with chamber. That's the pipe that goes with chamber. So you bring this pipe from this part. You bring this pipe from this part down to this part. Okay. Then you come to this part, down to this part. Then you come down to this part. Being the sockaway, this is the sockaway. This is the sockaway. So you are supposed to run this. The shortest distance for this connection, the shortest distance for this connection, in case you want to do it, is through this process. You can bring it from here, pass through the front of the house down to this part. Then you bring this from here and down to this part. That is the shortest distance, but that is the improper distance because you'll be needing chambers at the front. You'll be needing chambers at this section. You're only advised to use this method if you are working a chamberless design. But if you are not doing a chamberless design, you will be needing chamber for all these things. So automatically, this is a 4-inch pipe that comes to this part, and a chamber is highly needed. A chamber is highly needed here. A chamber is highly needed here. You can see. Then from this part again, a chamber is also needed. A chamber is also needed, and the 4-inch pipe has to go in. The 4-inch pipe has to go in. You can see. Then from this section, we need another chamber here. Then we need a chamber at the edge. We need a chamber at the edge. Okay, you can see. Then from there, we need another chamber at this part. Then we need another chamber at this part. For the waste pipe, we are having a waste pipe here. Don't forget, we are having a waste pipe here for the floor waste. The floor drain will be connected to the waste. So we are having a floor drain pipe here, for example. This is the floor drain. The floor drain pipe is here. Then it will be connected to the supply, to the discharge of the we are having another discharge. After this floor drain, we're going to be having another supply. After the floor drain, we are having another supply. Like, so automatically we can bring this chamber to this part. So the pipe has to run straight. Let me explain. Now we bring this chamber to this part, then we have a direct connection to it. We have a direct connection, and we are also having this. This is 2-inch waste pipe. This is 2-inch waste pipe, and this 2-inch waste pipe automatically the washing machine waste will be connected to this pipe for easy discharge. Then the next place you need a chamber is right here. You need a chamber here, you need a chamber here, and you need a chamber at the edge. You need another chamber right here. So in case you don't want to be using all these chambers, like I said, if you want to save cost, you can run it through, you can run all this calculation through the front of the building. You can run them all through the front of the building, like the first process I indicated, or you work all these chambers. The chambers are much, so I will advise you change your design. Now this is this safety tank. So if you are going through this method, you need all this chamber to get to this sockaway. But if you are going through this method, you only need one chamber, two, three, four, five. And besides, since this is just waste, since this is waste, that's why I said most of these mechanical are jobs you do on ground. That's why you have to be grounded in all these jobs. There are things you do on ground. Like since this is just waste, if you check this kitchen very well, this is basically just waste. And if you don't want to experience any future blockage, if you don't want to experience any future blockage, you have to use your 3-inch pipe. You have to use 3-inch pipe to discharge this sink. Then you step it down, you step the 3 inches upwards to 6 inches. You lay a straight 6 inches pipe direct to this pit without you using chamber. You just lay a 6 inches pipe, heavy duty 6 inches. There is no how, I can't say because there is no perfection, but there is, you have 90% chance that there won't be blockage. So you won't be needing all these chambers. You just lay a 6 inches pipe, you use 3 inches to connect it, then you step it up to 6 inches. Then you lay it straight one way. You calculate the slope one way down to this part, down to this part. Calculate the slope down to this part. And you have saved yourself the cost of all these chambers and wastage of pipes. And wastage of pipes. Then secondly, you can also do the same thing. You can also use the same 6 inches to lay, or if you are doing a chamberless design, always make use of 6 inches. If you are doing a chamberless lane, don't use any size rather than 6 inches. Always use 6 inches for that. Use 6 inches for that in case of blockage. In case of blockage. So, but if you want to follow the main procedure, that's the first thing we just did, you applying the chambers. So you can see this is for the water and this is for the waste management. So in case you are just coming across the channel, please don't forget to subscribe to this channel and don't forget to turn on the notification bell so you don't miss out our lovely class. For our next class, we're going to be doing the complete detailing on mechanical, from scratch down to the labeling. We're going to be labeling everything that needs to be labeled from our next class. See you next class.